Hi and blessings to you. In this video we're going to be going over managing permissions of files and directories by going over this task report that I put together when I was in the Google Cybersecurity Plus class, which is great. You can find it on Coursera.com. If you're just looking for the command, it should be showing up on your screen right here. But if you want to learn a little bit more about that and stay on my video, it does not help my videos at all for you to click on the video and to click right off. Then stick around and you'll learn a little bit more than just the command, so you have a better understanding of what you're doing. We'll jump in just about now. Yeah, how about now? So in this task, we display awesomeness by doing these 6 steps. And the first step is FSH navigation. Now, if I wasn't sure what FSH navigation was, then, even if I'm in front of other people, like maybe I am right now, I don't know, all 3 of you, then I'd just go to Grok, say, hey, I don't know what FSH is. So let's use some AI to tell me what FSH is. So here you see that I've typed in what is FSH in terms of the Linux CLI, and we learned that FSH is the fish shell. It stands for Friendly Interactive Shell, and it is a user-friendly interactive command shell designed to be more intuitive and feature-rich than, say, Bash. Bam. Took about 10 seconds, right? That's all, just a quick 10 seconds. And now we know that we are in the fish shell, and we're logged in. First thing that we want to do, first step, is make sure that we are in the proper working directory. In this lab, the proper working directory is the file path researcher /projects. And within the projects directory, we have all of these files. So you see right here that we have the read, write, and execute permissions. We're going to go into my CLI quick, and I'm going to show you the difference between listing just the files and the files with more information, so that we can see this stuff here. So we're not in the lab's FSH, but we are in my CLI here. And in the making hash values from a previous video directory, we can type in ls. If you already know this stuff, skip forward about a minute and we'll get through this. If you need a refresher or you need to learn this, here we are. ls is list. It lists the files. And here you can see our files. Now, if you want a more verbose display of the files, you type in ls with the option or modifier L. The modifier L, that's what gives you more information, including the permissions string. This is a 10-character string, as we'll learn here in a minute. You see this first dash? That first dash, that is a character that tells you if it is a file that you're looking at or a directory. It's a dash when it's a file, and it is a D. That's a D when it is a directory. And one more bonus for you here. ls-l is our previous command. Now if we put an A in there, that's also going to display our hidden files. And as a cybersecurity engineer, you may need to know about your hidden files on the directory if you're doing some forensic work. Let's go over again what this 10-character string is all about. If you already know this, skip forward about a minute and you can go on to the next one. So the first character, as we said, it indicates if the item is a file, dash, or directory D. Then we have the next 3 characters in the string. Characters 2 through 4, they indicate the permissions for the user. It's a 3-character string for the user, and that is read, write, and execute. And then it's the same read, write, and execute for the group, or read, write, and execute for others. The 3 set strings are in order as follows: read for R, write for W, and execute for X. Where the letter indicates the permission, So if it's got the letter, the R, that means it's got the permission, or the W, it means it's got the right permission. And if it's just a dash in the read location, then it means that the document is protected. And then we've got read permissions. They give you permission to read. The W, the write permissions, give you permission to edit the file or item. And X for execute, they give you permission to run or open the item. So here are our command semantics if you want to pause and take a look at the command semantics involved in making sure that you're in the right directory and then listing the files that are in the directory. Next, what we're going to do is we're going to do further directory investigation. And we can skip this step because we already learned that -A gives us the hidden files in the directory, and we want to see all of them. All of those files and directories within our directory. So now we get into the juicy stuff. Now we're adjusting permissions. So no item in the project's directory should have write permissions for others, users. We're in a situation right now where the security posture of our organization requires that other users do not have write permissions. So how do we adjust our file to make sure that it falls in line with company protocol? What we found above using the ls-la command demands that we change write permissions for the project K file. So how do we do that? We do it with chmod. That's right, chmod. So in this particular instance, the command looks like this: chmod o-w project k.txt. So here are our command semantics here, chmod, and then we got our permissions string followed by the file or directory that we're trying to adjust. If you're a little bit confused, stick with us. We'll go over it again here soon and it'll start to sink in. Modifying restricted file permissions. The demands of a restricted file are showcased here. We've got Project M. It is discovered that we must harden the organization's security concerning this particular file, Project M, by ensuring that only the user has read and write permissions. So the user is the first set of 3 characters after the first character. We should see an R, W, and a dash there, and then nothing but dashes after that. So a previous screenshot 2 shots back shows us that the group has read permissions on the restricted file. So here is Project M, and this is what it's supposed to look like. But this is what it currently looks like. Project M. We see that there are read permissions for the group. So we need to get away from that. So chmod, here's our permissions modifier section, and the G stands for group. So that's what we're adjusting, the group. The dash tells our computer what it is that we're adjusting. We are adjusting the group to have restricted what kind of permissions? Not execute, not write, but read. So group restricted read permissions on this file. It's that simple. That's how you take care of it. And then ls-l, this helps us to check our work, and we see that this is our command, and then we check ls-l and we see that it worked. Great job. We're coming up on the home stretch. Can you smell the hot wings in the distance? Oh yeah. Who doesn't love hot wings? So let's modify hidden file permissions. We discover that a hidden file has permissions that do not line up with the security protocol. We adjust the permissions of the hidden file. So .projects_x, that's our hidden file. And we see here that it only has read permissions. That's what our goal is. So how do we get it to that place? So we're going to do chmod. So U and G. U is for user, G is for group. So for both the user and the group, we are taking away permissions for the write. We are protecting the write permissions. And it's that simple. Then we check it, ls-la, and we find our projects.txt, and we see both the user and the group have no write permissions. We did it. So here's a little bit of additional technical info, some repetition to help you understand what's going on here. We know what ls-la does. chmod ug-w. The UG indicates that the user and group strings will be modified. The dash indicates that the modifier is to protect the archived file. And finally, the W indicates that the write permissions will be modified. This leaves the archived file, file X, with only read permissions on the user and group and no permissions for other users. This is indicated by the string. So the dash is telling us that it's a file. The R is telling us that the user has read permissions, and there are no other permissions indicated by the next characters here in the string on the .project X file line. Again, note that the period preceding the hidden is preceding the hidden file, indicating that it is a hidden file. So what if we want to grant permissions? So the previous task protected permissions. However, as indicated previously, both user and group need read access to hidden file project X. So let's grant access in this step. So here we do chmod. User and group, they both need write permissions, so we indicate that with a plus. So the user and group plus need read permissions for the particular file. ls-la indicates that here we've got read and read permissions for the user and group. So again, the U command is unnecessary as the user already had read permissions. However, it did not affect the outcome in a negative way if we did use the U. See, we did use the U, but it did not affect the outcome in a negative way. So I made a mistake there. I thought we were changing the group and other as I was indicating with my mouse, but we were changing the user and the group, excuse me. So this command produced read permissions on project X for the user and the group. The user already had the permission, the group didn't, but UG plus R did the trick. So there's the home stretch, my friends. That's how we hardened our security posture. Various modifications were made to harden the security posture of the organization, thus showcasing two of the chmod applications, including protecting and granting permissions for both hidden and non-hidden files, as well as restricting access to a restricted file. These are examples of daily tasks which a typical cybersecurity engineer will be completing in order to protect a company's assets and ensure the company is not restricted, so restricted that its members are unable to function, but restricted enough to ensure that the company's assets are secure. So many people in this generation are preaching about how they want to make a difference in the world. Well, if you want to make a difference in the world, being a cybersecurity engineer is one way to do it. The report could have been made longer, but out of respect for your time, I truncated the final task associated with this workload. Those tasks included modifying permissions on directories, further cultivating a salubrious digital environment for the members of our organization. You know, generally being awesome, like hot wings. I mean, really hot wings. Those are awesome too. Don't you agree? Well, speaking of hot wings, I'm off to enjoy some hot wings. God bless the work of your hands today. Friends, if you're on the blue side of things, keep your finger on the pulse of your organization day by day, making a difference in the world. If you're on the red side of things, my friends, hack with love, not with hate, making a difference in this world. All right, my friends, God bless the work of your hands.